Good morning. Abdullah Imran over here, and I shall be focusing on the topic of surface defect detection and classification from images, and I shall really not be getting into a lot of technical details. Data exploration, in which I analyze the data, did a lot of data pre-processing, data labeling was one of them, checking the color formats, checking every sort of things that could have been incorporated in this step before I moved on to the feature extraction process, in which I used a lot of feature extraction methods, but in my feature set, I pinpointed out to only four. One of them was A to G. So A to G does pick up a lot of errors, but does leave minute errors. Gabor filter specifically would pick up more errors than the A to G. Then Canny detection was the best one. It could pick up basically every sort of error in my particular scenario. A Wavelet Transform I implemented it because it was an interesting idea. It basically reflects the paper through different graininess process or different resolution processes to see if it could still pick up the defect on the paper. Then in dimensional interval detection, I specifically apply PCA. I set the threshold to 90% because over here you can see the curve sort of straightens after a particular point. So I reduce the number of features or components to quite a lot actually. Model building, in which I had an issue of class distribution errors, particularly in the holes area. So to address this, I used oversampling and undersampling methods. Got the initial accuracy that was very good, but not great as per my standards. So I applied gradient boosting on it and got a very high accuracy of 0.99 and 0.79 respectively. I used Gaussian naive Bayes just for simplicity and used basically the exact same methods I used in the logistic regression. SVMs, I pre-applied this Morton Rust and I did not specifically apply the gradient boosting on this or any ensembling method because I used an iterative process of improvement rather than, using a different sort of thing that, sometimes leads to even errors. I specifically used radial basis function kernel RBFK and gamma for flexibility and generalization. NNs or neural network areas is where I got the most errors. I ran, multiple neural network models, at least eight of them that I built. Even more I tested and through iterative methods, but each were predicting basically the same set of errors. You know, their accuracy wasn't really that high. So in few of the NN models, the epochs uh, were 50 plus with 30 iterations each, which basically takes a lot of time, but it was still not that successful even after applying multiple ensembling methods and multiple neural networking models combined into one. It was still, you know, making the things a lot more complicated and was not even solving the issue. So that's what I did. What any logical person would do to exclude it through in the model combining phase. So I only considered naive Bayes, logistic regression, and SVM. That does not mean that I did not apply neural networks. So I did specifically apply them multiple times, but I to attain a high accuracy of zero point 0.9 and 0.81%, as you can see, even after combining, uh, which I did through ensembling methods, voting classifier and soft voting, because these two particular ensembling methods in this particular scenario were really helpful than the other two. One was the gradient boosting. Defect localization was done in the end, which was, the last process before I sort of wrapped up this product. So thank you, and if you guys have any questions, please let me know. Thank you very much, and have a nice day.